How are you today? Are you okay? I really hope so. And yes, I just opened my fucking beer. I love to drink that fucking shit. And today we are going to talk again about the ransomware, but in this time we are going to explore a hybrid way. It's exactly what the RAAS actually do in the internet. It's the ransomware as a service, okay? Showing you guys how to make a hybrid and cryptography in the to the files, but it's not the purpose you to commit crimes, okay? It's just for knowledge. I have tried to make a simple code with my own fingers without import some libraries to use the class and so on, and so you get lost what is happening inside the algorithm. So in that case we are just using just one the fernet, okay, to create the symmetric key. It's the AES encryptor. It's symmetric key. It means that with the key you use it to encrypt it, it's the same key you gonna use to decrypt the files, okay? So in the ransomware mode you need to use the symmetric key to encrypt the files, and after that you need to use the asymmetric key to encrypt the symmetric key. Okay, that's a little confused, but if you are watching my videos and you gonna get it, I pretty sure of that. I don't intend to type out the code, so we are going to talk together, but I'm pretty sure you have watched my videos before, like the hunter and the encryptor videos, okay? So with those two videos you can watch this one, a hybrid encrypto ransomware. And so let's talk more action. Let's run the asymmetric key generator, and we have created the symmetric key. It has 44 types, and if we use the each types represent 6 bits, so we have 44 multiplying the 6, we have 264 bits. So this equal in the last file, it's represented minutes 1 byte, and 1 byte it's 8 bits, okay? So it's minutes 8. So that's the complexity of the symmetric key, 256 bits. Okay, it's 2 to the power of 256, which represents, if you want to know the complexity of that one, it's 10 to the power of the 77. That's pretty high. You can bet your life on it. Now we have created the symmetric key. We can go to the asymmetric key generator, okay? We have typed this algorithm in the previous video, but in that case we are going to use the 2048 primer complexity, so we can plus the P and the Q, so we have the 4096 bits of complexity. That's so much more than the symmetric key, like we said, like we saw. We had 256 bits, 256 bits, and it's pretty low. That's why it's pretty interesting to encrypting with the asymmetric key, the symmetric key, okay? We can use big complexity to encrypt the symmetric key, and with the IAS complexity encryptor we can encrypt all the files, and with the asymmetric key we gonna encrypt the symmetric key. Let's create it the asymmetric public key and the private key. The private key it's gonna keep with the hacker, and the public key you can send it to the victims, okay, when you explore some vulnerability of the server, and you can run with the file here. So let's create it, the public key and the private key. There is it, this asymmetric private key. That one I can't show to the victim, otherwise they would be able to decrypt the files. So that asymmetric public key, that's no problem, that we are going to send with the encrypto.py, in that case to encrypt all the file in the computer to get the reward page, like simulating the ransomware. Okay, so we have created all the key, and you can see that it's pretty long key. That's the complexity of the 2048, like here, the P and the key 2048, and we have plus those type, and we have 4096 bits. Okay, so we are going to encryptor.py. We have the file here. I'm calling the fernet to read the symmetric key with the read in binary mode. So we're gonna read the file, the symmetric key. We're gonna path the place, the directory we are intend to encrypt. In that case I'm using the desktop test. It's the test directory in the desktop file, but if I remove the test I would encrypt all the desktop, and if I remove all that sheet and press the C column, and we're gonna encrypt all that sheet on the machine. Okay, that is because I said to you we are going just to test it in the directory, in the test inside the desktop. So let's go on. There is the calling to the root juice and file, and we are going to walk in the desktop. So here I'm calling the I in files, I'm calling the files, so I'm running each files here, and I'm giving the variable name to call the path, and then direct and the file name, so we have the complete path to each file inside the test. Okay, and here I have created a conjunction, okay, to get the files minutes than 5 megabytes. We have the 5 multiplying the 1024. In that case we can see it's the complexity of the kilobytes, and if we use to the power of 2 we have the megabytes, so it represents 5 megabytes. Okay, so I'm calling to encrypt all the files lesser than 5 megabytes. It's just to run the algorithm in less sort of the time. Okay, so in the real case the hacker would run this ransomware without this conjunction, so he would wait you pause to use the computer, so he would run the encryptor, and for a short time of he gonna encrypt all the files. So in that case it's experiment, and we are giving the selection of the less than 5 megabytes. Okay, so we are going to open the file dir, okay, like in the read in binary mode, read file, encrypt the cipher. We are going to call it the fernet key, and we are going to encrypt the file. So here we are going to save the we are going to write in binary mode. We are going to save the file inside, so we are here writing inside the file. Okay, it's the intention to write inside the file, so it's gonna be encrypted inside, so you're gonna lost what it were before. And we write it and continue. Here we are open the asymmetric public key. We are passing the values of the public key and the n. We are calling the symmetric key, reading it after decrypt all the files. Okay, and we are going to encrypt the symmetric key, that one. Okay, and we're gonna to save inside I mean within the symmetric key. Okay, and so we are going to lost that asymmetric key values in the base 64. And if you got it with the encrypto file, the symmetric key, and the asymmetric public key, we send those three files, we are going to be able to encrypt whatever we want. So the decryptor, it's the payback. Okay, it's like the ransomware as a service. If you pay me back, I give you the decryptor.py with the private key, so you can decrypt all the file and run with your life. The decryptor, it's almost the same thing, but we first need to decrypt the symmetric key, so we gonna use the private key. That's the meaning of the asymmetric key. Okay, we need the private key to decrypt all the file. We are encrypting with the asymmetric key, in that case the RSA. Okay, so we are going to decrypt it with the private key. We ready the D, in that case it's the private key and the n value, and we pass the symmetric key. We gonna read it, and here we are going to decrypt it, and we save, what the fuck, decryptor, and we're gonna save the symmetric key values, original values. Okay, and after that we are going to decrypt the symmetric key. Okay, so since we have the original values, we'll call it again with the read in binary mode. We call the cipher, we run the path, and we are going to use all the thing, but here we are going to decrypt the files, and here we are running all the file in the path. In that case it's the directory test, but as I said, if you use the C column, you're gonna encrypt all the file in the window, and if you are using Linux, you run on the path the slash. Okay, and you are going to encrypt all the Linux directories, and it's gonna be all destroyed. I mean, since you cannot restore it with the asymmetric private key. Okay, that's the intention of the answer as a service, to get the remuneration of the pi back in most of the case with the crypto coins. Since now I have explained all to you guys, let's have two icons to create the encryptor and the decryptor.py, the exe, okay, and the angry icon. Let's use the happy icon to encrypt it and the decryptor with the angry, okay. That's just to make it kind of crazy. So I have installed the PyInstaller here already, and now we need to make some command like the PyInstaller. Let's call it the one file window web icon. Let's call it the happy.icon and the encryptor.py. Hope everything gets typed correctly. Happy it's not correctly. Happy icon and what the fuck? Encryptor. There's it. We are creating the file. Inside the disk, there is the file. View larger icon. Wow, what a nice icon. He's so happy. I want to execute it. Okay. Let's run it first. We have the folder test. In the test we have typed the test inside, and inside the folder we have two pictures of the Baba Yaga and the Mr. Pickles. Okay, we have a file with 6 megabytes, so we have created the conjunction of the 5 megabytes like we saw before, so that file won't be encrypted, and we have the peer-to-peer of the Bitcoin here with less than 1 megabyte, so it's gonna be encrypted. So let's call it back. Let's go here and execute. Oh, it's not gonna work because I don't have the motherfucking asymmetric public key and the symmetric key. Let's call it inside. That's the file the ransomware needs to send to the victim. Okay, now let's run it, and nothing happens. Okay, so let's check the test. It's encrypted, and let's see the folder. Let's open the Bitcoin. We cannot open it, so that one with 6 megabyte, it's not encrypted. We can run it, and the files is encrypted either. So all inside the test will be encrypted with that algorithm. That's the purpose of that shit. So now let's create it, the decryptor, okay? Like the victim have paid for the decryptor handle. And another thing I'm gonna show you, if the victim try to access the asymmetric key. Let's try to open it here. No. That's the key. It's encrypted. That's not the 44 types in the base 64 like we have seen here. That's not the same, okay? It's encrypted by the asymmetric public key. So to decrypt it, the symmetric key, we need the private key, okay? That's the point of the ransomware being service, like I said before. And now let's create it, the angry icon. It's the decryptor and the angry icon. Let's create it. It's gonna be created in the dist folder. There's it, the decryptor file. It's the angry executable. So we pass to the victim that paid the service the decryptor exe and the asymmetric private key, and we say, hey guy, run that fucking shit and we'll gonna be restore all your files. That's what the ransomware do, okay? We are simulating the action here, but like I said, it's just for knowledge, not helping you to commit crimes. Just it lover, okay? I love coding, and I love to see how the ransomware works and so on. That's the purpose of this YouTube channel. So let's run the crypto file. Let's open here. Nothing's happening here. Let's run it, and it's done. I'm gonna click here and update. There's it. The folder has been restored. The Baba Yaga and the Mr. Pickles and the Bitcoin PDF. We can watch it again, and that one didn't change because it have 6 megabytes more than we have created the conjunction and the test. Let's type the test inside, and the symmetric key. Let's watch it, and there is it. We have restored the symmetric key. Okay, there is it. That's how it's work. The hybrid, the ransomware, okay, with the symmetric and asymmetric key. I hope you have enjoyed that video. It's pretty awesome. I like it so much. So if you like it, either thumbs up, subscribe for more videos, and that's for now.